So, welcome to machine learning training program, and in this particular lecture we're going to talk about neural networks. Okay, so let's take the same example of logistic regression. Let me tell you the same example of the logistic regression. Let's say this is our x-axis and y-axis, and this was our logistic regression model, let's say. And the people who are and the students who are falling above this white line, above this model, is going to be accepted in the university, and the people who are going to be below this white line are going to be rejected through in the university. So basically we have the grades as y and entrance test as x, and whatever the coordinates of x and y is going to be, that coordinate is going to be fall on any of the plane, and whatever the plane is, we are going to accept the student based on that or reject the student. We talked about a student who was having the marks as what, 9,8. Okay, 9,8, and he was accepted in the university. Okay, so let's say there is a student whose marks contains grades as, his college grades are, let's say, 8, and his entrance test was 1. This was the marks of a particular student. So what do you think? That student should get accepted? So that student will be, if I plot the 8,1 here, so let's take the 8 as grade. This is your 8, okay, and this is your 1, and 8,1 is going to be your marks. 8,1 is going to be marks. So 8,1 is basically is getting accepted according to this logistic regression model. According to this model, this 8,1 guy is accepted in the university. But there is a problem here. This is not how real world scenario actually work, because in real world scenario we don't accept the student who is who have scored really less marks in the entrance test. So we don't want to we don't want that student to get accepted. So maybe we did something wrong in dividing the data, because we draw a straight line and we considered that the data that is going to fall above is going to be accepted, otherwise it is going to be rejected. But maybe the data will look something like this. We are not going to accept the student who is going to be scoring high grades and low test marks. We are not also going to accept the student who's going to have the entrance test high and low grade marks. We are also not going to accept that student, right? Maybe the data look like this. Let's take a new page. And let me draw the data set again. This particular area of data set is having high test and high grade marks, and otherwise if you have any one of these low, it is going to be rejected, or both of these low, it is going to be rejected. So that is why maybe the data set is looking like this. So to divide this data set using a straight line, so let's say this is how our line is going to be drawn. So as you can see that it is not able to divide the data set perfectly, because it is having a lot of misclassification actually. And let's say the data set would look like somewhat this. Anywhere you draw the line, it is not going to divide the data set into two parts. The green side should be on one part and the red side should be on other part. It's really difficult using a straight line. If you draw the straight line like this or something, it is giving us the wrong output, because lot of misclassification data is there. Okay, so basically that is why, like, maybe this solution is not perfect, maybe the straight line solution is not perfect, maybe the exact solution that we want is going to be somewhat like circle or something. Okay, let's try to draw a circle here. So if you draw a circle to divide the data set like this, okay, maybe like this, it is going to solve a problem, right? It is definitely going to solve a problem. The circle can divide a data set, and let's try to do it using two straight lines. Okay, one straight line is going to be like this, and other one is going to be somewhat like this. Okay, let's take the another color for this. So let's take the blue one for now, and it is going to be somewhat like this. Now the data set has been divided, because whatever the data is going to fall right of the white line is going to be accepted, and above of the blue line is going to be accepted, otherwise it is going to be rejected. So if the data is going to fall in this quadrant, then only we are going to accept that particular student. So whenever you're dividing the data into lines, okay, onto multiple lines, you are basically performing a neural network. This is exactly what a neural network is. Let me tell you in a brief detail. basically whenever you are implementing a neural network, you ask three questions from the data. You ask three questions. Let's take the two lines for now. Let's take that this is a neural network, this is a neural network, this is a neural network basically. And whenever you are dividing the data, you ask three questions from that. Okay, you ask three questions whenever you are dividing the data into two parts using two straight lines. That means you are using a neural network. So let's ask those three questions first of all. Okay, the question number one is going to be that whether the point, whether the point is right of the white line or not. Okay, is right of the white line or not. So let's say that, the question is going to be right of the white line or not. So, and the second question is going to be, whether the point that you're talking about is above the point or not. It is going to be in 0 or 1 answer, yes or no. Okay, so if we talk about the, if we talk about what are the quadrants will look like, so this is how the quadrant will look like. That, for this question number 1, if it is going to fall here, yes. Okay, and for question number 2, okay, it is going to somewhat fall here, which is yes. Okay, this is the yes. Right of the white line and above the white line is going to be yes, yes. In the same way, here we are going to get the we are going to get the yes and no, yes. And for the blue line, it is going to be no, because the point is above the, sorry, not this one, this is let me just remove this. So the white line is going to be no here. Okay, the white line, let me do one thing. Take the blue line first. Okay, so the blue line is going to be yes here, the blue line is going to be no here, and the blue line is going to be no here. In the same way, white line, for white line, it is going to be yes, no here, because it is left of the white line, and we are asking whether the point is right of the white line or not. And then here again we are going to have no, and here we are going to have yes, and here already we have yes and yes. So the question 3 that is we are going to ask, that whether a line that you're talking about is whether the question that you have answered in our first two questions, the answer of first two questions are yes or not. Okay, that means we are applying the AND operator. We are asking basically whether the question that you have asked in the question 1 and question 2 are both yes or not. If both the answer are not yes, then the student will not be get accepted, and if any of them is going to be no, we are going to reject that student. And that's exactly what an AND operator is. So this is what the question that you're going to ask when you are going to implement the neural networks. Okay, so as you can see, we cannot just fit the data point. Okay, as you can see, we cannot just go on and fit the data point. Like if you have the data point as 1,8, you cannot just ask these two lines directly. So that is why we are asking these three questions from that. That if you want to put 1,8 into this graph, you have to ask these three questions from that. That this point is lying right of the white line and above the blue line, then only it is going to be accepted, otherwise it is going to be rejected. So that is why these three questions are being asked in the neural networks. Okay, so let me show you how exactly a neural network will look like once we convert this graph into a proper node and diagram and node and layers diagram. So let me implement that. So first of all, you're going to have the test. Okay, you're going to have the test. Okay, and you're going to have the grades. Okay, and test is going to be, let's say, 1, and grade say is going to be 8. That is what the example we took. Okay, whenever you're taking this example, you are going to implement the neural networks. Okay, whenever you're taking these kind of examples, that means these two-dimensional data. And let's implement that. Let's take the straight line, let's plot a graph here. So let's say this is a graph of ours of x and y axis, and these two data points are going to get inside this graph. Okay, it is going to get inside the graph. So what the graph will represent? The graph is going to represent the straight lines. The graph is going to represent the straight line one by one. That means we are having two lines here. So we're going to check for the two lines here. So let's grab and let's draw two lines first of all. So let me draw the blue line first. Okay, let's draw the blue line first. So let's go to the straight line and we are going to draw line here. So just a second, let me remove this. So the line would look somewhat like this. Let's say the line would look somewhat like this, let's say. Okay, and the data point that is above this line is going to be accepted. The data point that is above this line is going to be accepted. Just a second. It is going to be accepted, and the data points that are going to lie below this line is going to be rejected. Okay, and that is exactly what a question 1 is. That is exactly what a question 1 is. That question 1 represents that whether the point that you're talking about is above the blue line or not. Okay, above the blue line or not. That is what exactly a question is. Okay, so you have this question 1, and now what you're going to do, you are going to basically pass all the data inside this graph, and you will get an output. So let's take the example of 1,8 only. So let's say 1,8 is going to somewhat fall here, because test is 1, test, and this is the grades. Test is 1, this is 1, and this is 8. Let's say 1,8 is going to lie here. So the answer you're going to get here is going to be yes, it is going to be accepted, because it is lying in the accepted region. After that you're going to have, again, test is equal to 1 and grade is equal to 8. Test is equal to 1, grade is equal to 8. And what you can do, you can simply draw a line here. You can simply draw a line, and now you're going to grab the second model, which is the white line here. You know, this white line, we are going to grab it. So let's grab the second model, which is the white line. So let's draw a model there. Okay, let's draw a model there. Okay, and once you draw a model, we are going to basically put in the accepted region, and this is this is going to be accepted region, and this is going to be rejected region. This is going to be rejected region. Okay, now you have this accepted and rejected, and now you're going to pass the whole data here inside this graph. Okay, you're going to pass the whole data, which is test, x is going to be test, and y-axis is going to be grades. Okay, now you're going to pass whole data here. You're going to pass the whole data, and we are going to present the output, here. So the 1,8 point is going to somewhat lie here. 1,8 is going to somewhat lie here. So based on this 1,8, it is lying in the rejected region. So that is why it is rejected. It is being rejected here. And now the question 2 was, remember the question 2 was whether the point is lying right of the point or not. Okay, whether the point is lying right of the point or not. You can see that right of the point or not. If the point is not in the right, that is going to be rejected. Otherwise, it is going to be accepted. Okay, now in the third question, remember we talked about in third question that we're going to apply the AND operator in the end. Okay, that means if both of these question is going to be true, that is only where it is going to be true. Otherwise, it is going to be false. Okay, so we are going to perform the AND operator. So let's perform the AND operator first of all. Okay, so these two are going to get passed in the AND operator. So let's grab this, and these two are going to get passed in the AND operator like this. This is going to be here, and this is going to be here, and this, just a second, this is going to be the AND operator we are going to have. Okay, so yes and no, and putting the AND there, it is going to be no, definitely. Okay, it is going to be no in the end. Okay, because yes and no, it is going to be no. So in the end, we got the answer as no, the student is not going to get accepted. Maybe you have some unanswered question. So that is why I'm going to explain this again, what I've just talked about. What we talked about here is, you are having some university students here. Okay, you are having some university students here, and you draw the, first of all, logistic regression before. And when you draw the logistic regression before, you came to know, that we are accepting the student that we should not accept. That means if the student is having the less test marks, the entrance test marks, and high grade, is still that person is not going to get accepted in the university. So that is why we decided that let's explore the data more. Maybe we have considered something wrong in the data set. So then we came to know that we really considered wrong in the data set, because we were accepting those students also who are having less grades and less test marks. Okay, based on this logistic regression line, we were accepting those students also who were having low test marks and high test grades. Low test marks and high test grades. All of those people were accepted before. So that is why we draw a two lines to divide the whole data set. We draw two lines to divide the whole data set, and that is what exactly a neural network is. Neural network draw lines in the data set one by one, and as much as you increase the layers, it is going to increase the lines. But I'll talk about layers later on. So for now, just remember that neural network consists of two lines. For now, just remember that neural network consists of two lines. Okay, so you're having these two lines, which exactly what neural network is representing. Whenever you're dividing the data into two lines, using two lines, you are implementing a neural network. Okay. So you're having a neural network here, and whenever you are implementing a neural network using two lines, you're going to ask three questions. The first question is going to be whether the point you're talking about is right of the first line or not. That means the first line is, let's say blue. It can be anyone, but let's say here it's white. So whether it is right of the white line or not. So the answer we are going to get some answer here. Then in the question 2, we are going to ask whether the point you're talking about is above the blue line or not. Then you're going to get an answer there. And in the question 3, you're going to talk about the answer that I have given in the first two questions are going to be yes or not, are yes or not, both yes or not. If they are not yes, then we are going to go for the class B, otherwise it is going to be class A. And class A here is accepted in the university, class B here is the rejected in the university. So if you got the answer both as yes, then only we're going to go for the accepted ones. Otherwise, we are going to go with the rejected ones. Okay. So for the 1,8, we tried to find for the 1,8. We came to know that 1,8 somewhat falls here. Okay. It somewhat falls here, which is 1,8. And when you saw that 1,8 is falling here, it is having yes and no as the answer. It is having yes and no quadrant. So that is why that person is not going to get into university. But I wanted to show you this in a form of neural network, how actually the neural network is going to perform this operation, in the hidden in the black box. So this is how the neural network will look like. You're going to have these inputs, which is test and grades, and you're going to pass on each and every model that you have. Okay, and in the end, whatever the answer we're going to get in the binary form, we're going to get the answer in the AND format. Okay. So let me clean this neural network a little bit and show you the original one, how actually the neural network will look like. Okay, let me clean this one. Okay, and this video is going to be long because it is a long video here. It is a long video. It's a very important concept we're talking about. So the neural network will somewhat look like this in the end. In the end, it will look like this. So this is how the whole neural network will look like. And if we talk about terminologies, this area is called as input layer. Okay, input layer. This area is known as output layer, and this graph one is known as hidden layer. So basically, as you increase the nodes, as you increase the layers, this is a layer, hidden layer. This is a layer, a number of nodes, and that is how you're going to implement in the neural networks. But whenever you're using neural networks for your projects, it is going to do that in the background itself. So you don't need to be drawing these kind of things, but your brain will be drawing these kind of things in the end. That is why it is important to understand these. Okay, so let me tell you where this concept is coming from quickly. It is coming from the concept of brains. Okay, we are having the brain. Okay, we are having the brain, and we have something known as neurons there, and you have these kind of things, and you are having the somewhat these kind of things, and you're having a circle in between. This is known as axons. Okay, this is known as dendrites. Okay, and these are known as neurons. Okay, you can say whenever a new signal comes, it is going to get here in the input, as an input is going to get here, and then it is going to pass through here. Okay, it is going to get passed through here. Okay, and it is going to get received, and electrical signal is going to get generated and then sent to the organ. And in the same way, we are having the neural network here. We are going to get some inputs. Okay, we are performing some things here, and we are getting some outputs. So this is how exactly, we are trying to mimic how the brain actually works. We are trying to mimic how the brain functionality actually works. Okay, so remember this, that whenever someone asks you what is a neural network, just tell them that neural network is the process of mimicking the brain, and we try to mimic the process of how brain actually works, and have some input layer, hidden layers, and we try to get some outputs. And now you may have this question that is this neural network consider only AND operation, or it is also going to consider OR also, or XOR or NOR? So I'll tell you this later on. For now, just remember this: we are having and just key takeaway is you're going to have the neural networks. Okay, whenever you are performing neural network, it is drawing multiple lines in the data set and trying to find the answer. Okay, when you have 2 lines, it is going to get the answer as the what? It is going to get the question, sorry, 3 questions, and if it is going to be 3 lines, 3 models, it is going to get 4 questions. Anyways, just remember this thing: you are having input layer, you are having hidden layer. Hidden layer is going to be having multiple models that is going to be implemented. And the model, I don't mean logistic regression, linear regression, k nearest neighbor, k means clustering. Forget about that in the neural networks. Neural network is going to draw lines in their own terms, and it is going to perform, in the end, it's going to perform AND operation. So that's it for this video. I know it was long, but neural network is a very important concept and you must understand this. If you haven't understood this concept, watch this video again, watch this video 2-3 times. You're going to understand this. And if it is not helping you, tell me in the discussion forum. Thank you so much. We'll meet in the next video.